fellas. We are doing lesson 91. Today's lesson is titled The Effects of Scaling on Perimeter, Area, and Volume. So we've actually already done a lot of this, so this should be a review. The main point of today's lesson, main part of today's lesson, I've given to you in your notes, I think maybe 2 or 3 times before. So here we go. So if we are given a square, so given a square and a larger square. Okay, so if we have a square here, and let's say that its dimensions are, sides dimensions are 1 unit long. And let's say our larger square has dimensions that are 2 units long. Okay, then we know that the ratio of perimeters is equal to the scale factor. All right, so the ratio of the larger perimeter to the smaller perimeter is 2 to 1, which equals the scale factor of 2. Right, to get from 1 to 2, we multiply by 2. All right, and I also know then that the ratio of areas is equal to the scale factor squared. So the ratio of areas, the area of this square has an area of 4. So the ratio of larger square's area to the smaller square's area, the area of this square is 1, is equal to the scale factor of scale factor squared. So scale factor is 2, 2 squared is 4. All right. And then let's say that these aren't squares but rather cubes. All right. And so they're cubes, so these are same lengths as the previous dimensions. So then I know that the ratio of volumes is equal to the scale factor cubed. So the volume of the larger square is 8, 2 times 2 times 2. And the volume of the smaller cube is 1, 1 times 1 times 1. So the ratio of volumes, larger to smaller, is 8 to 1, which is equal to the scale factor, which we said is 2, cubed. 2 cubed is 8. Okay? So, some problems that you might see, right? If I have a picture, take a picture, all right? Just like you would a photo album, you take a picture. And let's say that the picture is a square that is a 1 by 1 square. Okay? And then I'm going to take this picture and make a mural. A mural is a, painting on the side of a wall or something like that. So I'm going to use the picture that I have and make a mural out of the picture. Paint it on the side of the building, something like that. And we're told that the mural is 5 times bigger than the picture. Okay, so right there we're told the scale factor, right? So if I know that my scale factor is 5 because the mural is 5 times bigger, I know then that my sides are 5 and 5, right? And so I'm asked that if the mural is 5 times bigger and I buy 5 times as much paint, as I needed for the picture, will it be enough to cover this entire area? And so I buy 5 times as much. If I buy 5 times as much, will it be enough to cover the mural? Okay, so the answer is no, because my area here is 1, but my area here is 25. So if I buy 5 times as much paint, I will not have anywhere close to enough paint to cover the area of that mural. So we would know that too by taking the scale factor 5 and squaring it, because I would need to know the area, which is 25. All right. Something else that might be helpful is this kind of diagram where we have a bunch of squares. And so I'm told that this square is 1 unit in dimension, making the area 1, right? Unit squared. And then if I have a square that's twice as big, what's the area? Well, that would be 4 units squared. And if I have another one that's 3 units, right, in length, then the area is 9 units squared. And then if I have a 4th square with 4 as the units, then the area is 16 units squared. Right, so we can compare these to each other and say that this square and this square, right, this square is 4 times larger than this square. So the area will not be 4 times larger, but 4 squared times larger, which would be 16 times larger. Okay. And that should be it, right? So again, the crux of this lesson is this idea right here, which we've seen and should have in our notes. And so we're now going to be able to use this. We'll see a lot of problems where if we know this, we can use this as a shortcut to solving the problem. So rather than finding maybe the volume of the two cubes, right? If we know that the cube is twice as big in dimension as the original cube, then I know that the volume will be 8 times larger as well. Okay. So that will conclude the lesson. I'll take some pictures of the notes so that you guys can see those closer.